This summer's Olympics feature 3 disciplines of climbing: speed, bouldering, and lead. Speed climbing orients climbers in a side-by-side race of upward movement. Bouldering challenges climbers in short, intense, mentally challenging routes. Lead climbing tests endurance as climbers attempt to scale a course as high as possible under certain time constraints. Each athlete must complete all disciplines in a respective sequential order to earn a collective score for rank, which is why climbers must hone every skill to acquire a medal. Olympic climbing can be analyzed through lens of chemistry, biology, and environmental science.
One important tool used in climbing is climbing chalk. Climbing chalk is a pure form of magnesium carbonate. This can be formed through the purification of magnesite mineral, or it can be produced in a lab using a chemical reaction between a soluble magnesium salt, such as magnesium chloride, and sodium bicarbonate to form a magnesium carbonate, sodium chloride, water, and carbon dioxide. Magnesium carbonate is an ionic bond, meaning that it is very hard to break apart. 2 important properties of ionic bonding are lattice energy and hydration energy, which determine the solubility, melting point, and boiling point of a substance. As magnesium carbonate has a higher lattice energy than the hydration energy, it is considered insoluble. Sweat is mainly composed of water, so when climbing chalk is used, it decreases the moisture and sweat on the hands, allowing for better grip on the holds when climbing.
Modern climbing ropes are all made with the same thermoplastic core, polypropylene. Polypropylene is a synthetic thermoplastic polymer made from the polymerization of propylene. It's a linear hydrocarbon with 1 methyl group bonded by single carbon bonds. Its chemical formula is repeating units of CH2CH3. It is resistant to degradation from fats in almost all organic solvents except strong oxidants at a high temperature. Polypropylene is also stress resistant and has minimal elasticity, but is still flexible, making it optimal for climbing. Polypropylene is not biodegradable, although it is recyclable. It also has a high resistance to extreme temperatures, melting at about 160 to 180 Celsius.
The human musculoskeletal system is essential in providing structure and a means of movement. Within the system, bones are connected via joints, supported by ligaments, muscles, tendons, and connective tissues that reduce the friction of movement. Joints enable bones to move within certain ranges of motion, the totality of movement a joint can do. Active range of motion is a range of motion achieved when antagonistic muscle pairs contract and relax, causing joint movement. Healthy range of motion is vital in navigating complex climbing courses where holds and reaches may be configured in impractical positions.
Body fat content is usually around 6 to 12 for men and 10 to 18 for women climbers. This is to maintain a lean body type, which is important for strong muscles and minimal body fat. It's important for climbers to target the correct muscles that will help them and not act as excess weight when they're climbing. Climbers target these muscles: lats that extend your shoulders for better range of motion, abs that create balance and support, quads and calves push up from the body, and trapezoids and rhomboids connect to shoulders and pull the body up. A lean body type is created by eating lean proteins, fresh foods, and small amounts of processed foods and unhealthy fats. Eating protein reduces the hunger hormone ghrelin and produces satiety hormones that make the body feel full. Carbs are also important for short-term climbing performance, maintaining enough nutrients for the body. And electrolytes are important to avoid blood sugar and hydration dropping over long-term exercise.
The 2024 Paris Olympic organizers have made large strides to ensure the Olympic Games are eco-friendly. Some of these objectives include the use of renewable energy, reuse of manufactured materials, and use of low-carbon construction methods. These initiatives are revolutionary to the Olympic world, but are they enough? Constructing climbing buildings and walls generates a ton of material waste, and while some climbing construction companies try to reduce this, it's unclear whether the Paris Olympics has instituted the same policies. Climbing walls are always changing, and due to overuse or other factors, some usable pieces are discarded before necessary. To combat this, manufacturers can prioritize refurbishment over replacement and reuse pieces in new combinations or locations. Manufacturers can also shift to using recycled plastics rather than brand new materials. Finally, for a more sustainable Olympics, the climbing venue could consider trading the steel beams of traditional climbing walls for beams made of engineered wood. Overall, the Paris Olympics has done an amazing job at making the Olympics eco-friendly, but there's always more they can do to promote sustainability.
Overall, chemistry, biology, and environmental considerations all interact in defining climbing as an Olympic sport. Chemical processes assist in the creation of tools necessary for climbers, biological functions enable the practice of climbing, and environmental sciences explore sustainable approaches in establishing diverse courses to challenge athletes. The cost of resources, as well as the limitations of human physiology, may make climbing a less accessible sport to the majority. However, recognizing the scientific limitations to indoor climbing educates society towards developing sustainable solutions.